Friends, in this video we will learn the concept of amplitude modulation and so I have taken a problem from the previous GATE exam, and the question is: consider sinusoidal modulation in an AM system. Assuming no overmodulation, the modulation index mu when the maximum and minimum values of the envelope respectively are 3 volt and 1 volt. So here are the two terms. First, here it is given over modulation, and the modulation index we have to find, and the modulation technique that we are using here is AM system, amplitude modulation system. So we will first know the amplitude modulation system general formula of the signal, or you can say general expression of the signal of AM amplitude modulated system or signal, and also understand what is overmodulation and how the overmodulation can be avoided, and then we will try to solve this problem. So here I start. The basic general formula of amplitude, as we know, this is amplitude modulated. Amplitude means if we have a carrier like AC cos omega ct, so in addition to this amplitude, if means this amplitude is being varied by a message signal, of given message signal, then this will be called that it has been amplitude modulated. Means this is the given message signal, this is message, this is carrier, and when message is applied on a carrier, so if the signal becomes like this, means AC plus MT and cos omega ct, means there is no any effect in the frequency. This term is same, cos omega ct, only the magnitude of the signal is being affected. So this type of amplitude, or you can say the amplitude of the signal has been affected, so it will be called amplitude modulated system. And in general it can be further derived as this signal is amplitude modulated system AC, and further we will take AC as a common. AC 1 plus mu a MNT. MNT is what? MNT is the normalized message signal, and its value will be ranging in between -1 to +1. So MNT is normalized message signal, its value ranges from -1 to +1, and cos omega ct. Okay, so why -1 to +1 we are taking here? Because if its value mu a, as we all know, is less than 1, less equal to 1, and its value is between -1 to +1, so whatever the value of this one and modulation index 1 plus this value must be greater than 0 always. This must means envelope must not be less than 0, otherwise this will be called over modulation. So what happened to the over modulation actually? Means if I assume that this is a message signal, carrier signal, if some amplitude is applied, so it should not be like that the entire signal goes in negative or entire signal goes in positive. Means this should not be happen like this complete envelope becomes negative somehow in any manner. So it should never be in negative. So this is the concept of overmodulation. I will come with the overmodulation concept in some other videos. Here I will not go in deep with this one. So what is I'm concerned about here, this is the envelope that I am talking about. AC into 1 plus mu a MNT is the envelope of the message signal, amplitude modulated signal, and Mn is just in between -1 to 1, and mu is of course the modulation index that we have to determine. So this is the general form of the amplitude modulated signal, and the envelope is nothing but the amplitude of the entire signal. Okay, so for the given problem we know that envelope values, the maximum envelope value is 3 volt and minimum envelope value is 1 volt. So here we can use AC 1 plus mu a maximum envelope, AC 1 minus mu a as minimum envelope. So 1 plus mu a is equals to 3 and 1 minus mu a is equals to 1. So here I have applied AC1 plus mu a equals to 3, AC1 minus mu a equals to 1. So by solving, or you can say dividing, we can easily calculate mu a equals to half. So this was the generalized method, but alternatively we can directly solve the given problem by using a simple formula, and that is modulation index is V max minus V mean upon V max plus V mean, where V represent the envelope, the total amplitude. So the maximum envelope we just have checked. 3 is the maximum value and the 1 is the minimum value. 3 minus 1, 3 plus 1. So the divisor, after dividing we get the result 1 by 2. So this is the modulation index value of the AM wave. And so the technique that they used here is just a derivation of the above one, but you can use in exam directly to save time. Okay, so in this video we learn the general form of the amplitude modulation. We learn about the envelope of the amplitude modulated system, and also we know how to calculate the modulation index using the maximum and minimum values of the envelope by using this formula directly. So this was a very easy concept about amplitude modulation. I will come with some other concept in depth with amplitude modulation and some other topics in communication and other branches. Thank you so much for watching, and subscribe our channel for upcoming videos. Thank you.